Welcome back. In the last lecture session, I have introduced you to the concept of data structures and algorithms. And we have discussed an search algorithm called linear search. And we have written one program for linear search and executed that one using Anaconda interpreter. In this class, I will continue with the discussion on linear search with the second program, Lecture2.py. So here, it expects the list to be an ordered list. It must be arranged in ascending order or descending order. In this case, specifically ascending order. If the list is in ascending order, then it will say the search element is present or not, starting from the first element only. But the advantage here is if the search element is present at the initial positions, at the smaller index levels, then the identification is very easy and very fast. Quickly it will identify and gives the result. Whereas in this case, so it takes a lot of time. Minimum change has been made. A small change is made to the existing linear search1.py program so that it will work for only arranged list. Let me see the program. Let us open the Anaconda. This was the program that I have explained in the last class, linear search1.py. Let me go to linear search2.py. I will clear the console. See the difference here. In the earlier case, we had a program, a function is written in linear search 1. So it takes two values. There is one for loop, one if statement. It returns whenever there is an equal, otherwise it returns a false. Here there is a bit more. We have two if statements here, unlike in the earlier case. You see here in the main program, there is no change at all. I have taken the same list 9, 51, 63 up to 25. Totally there are 9 elements with an index starting from 0 up to 8. And call the search method search L25 if it is true. So here also I am sending two parameters. One is the list and another one is the search element. I have and then it will be passed to the method, and if it is successful, it prints given element is present in the list, otherwise given element is not present in the list. In the earlier program, in linear search 1, you see here I have a for loop which goes from the 0 up to the maximum, the last index. Each time the element is compared with the search element. If there is a match, then it returns yes, it is successful, it is the given element is present in the list. You see here a little bit change here. The range for loop is also here, starts from 0, goes up to the length of the list, which is 9, and the for loop goes n minus 1. So it goes, the value that I takes is 0 up to 8, 0, 1, 2, 3, 4, 5 up to 8, and my for loop is present till this step, return false. So here I have 1, 2, 3, 4. There are 4 statements corresponding to the for loop. First, when the in the very first case, for loop, I takes a value of 0. If L of I, the first element, which is 9, is equal to E is the search element. If it is equal, it returns true. Whereas in the earlier case, it goes back to the for loop. Whereas here it goes to the next step and checks whether this element is greater than the search key. L of I, that means the element at the ith position, which is 9 for the first iteration. If it is greater than E is the key that I have supplied here as a parameter. If it is greater, then it returns false. That means if the element at some position is greater than the search element, then it will not go for checking the remaining elements. It will simply return back to the main program displaying the element is not present, false. So if the return value is false, it prints given element is not present in the list. So otherwise it will continue. So in this case, it expects an ordered list L of I if it is greater. This will this statement, this if statement will see that if a smaller element is present at the later stage in the list, it will not going to check it. It will simply come out. Now let me give the same input that I gave in the last program. It is 380. 380 is my input. If I give 380 as input to this program, what is the output? It says given element is present in the list. 380 is present in the list. Now I will give 25 as in the case of the last program. Here also I give 25 as the input. If I give 25 as the input, let me see, in fact 25 is present in the list. The search should have been successful, but here it says given element is not present in the list. Why? It will search because it searches only the ordered list 9 after 380. It expects a number which is bigger than 380, whereas 25 is less than 380. In fact, 25 should be there after 9 as the second element of the list. So a linear search algorithm here is a bit modified case. This program is a bit modified one, where if I give an unordered list, unarranged list, then it gives me a result if the element is present above the list, above the last element of the list, the biggest element of the list, it gives me it is not present. So this is about linear search. So linear search is a very simple algorithm, and we have implemented here two different types of linear search algorithms. Let us go to the next one, which is binary search. Okay, so we have done experiment on binary search in microprocessor lab at 5th semester. Let me go through each and every step of binary search algorithm. As in the case of linear search, here also the first and foremost step is input the search element. So here in the last program, we have inputted it as part of the program, as part of a parameter. The calling value which calls the method or the function itself holds the search element. We can even input the search element through the user interaction after entering the input by the user through the keyboard. Second, the very important step here is find the middle element in the sorted list. Unlike in the earlier case, in case of linear search, it finds the very first element. The element which is present at the 0th index is checked with the search element. So whereas here it will go exactly to the middle of the list. If the list consists of 9 numbers, it goes to the middle one, 9 divided by 2. So 9 divided by 2 is 4.5. It will not take 4.5. Instead, it will go to 4. If there are 8 elements, then it will be 8 by 4. Then also it will go to the fourth position. So likewise, instead of going from the very first element in the list, it goes to the middle element of the list. You recall successive approximation technique of A to D conversion that you have studied in DCBA. This technique is similar to that one, binary search algorithm. Compare the search element, step number 3. Compare the search element with the middle element in the list. Now the search element is compared with the middle element. If both are matched, then display given element is present and terminate the function. Instead of going to the very first element, go to the middle element, do the comparison. If the comparison is successful, then display given element is present and terminate it. Otherwise, what we have to do? Otherwise, you check whether the search element is bigger than the middle element or smaller than the middle element. If it is smaller than the middle element, then you go to the earlier half, the smaller half. If it is bigger, then go to the next half. Next half means the sub list which is present after the midpoint of the list. Okay, that is in step number 5. If both are not matched, then check whether the search element is smaller or larger than the middle element. So middle element is very, very important, which will decide whether the sublist which is to be checked next is present prior to the middle element or next to the middle element. Let me see the next step. In step number 6, if the search element is smaller than middle element, Repeat steps number 2, 3, 4 and 5 for the left sublist. 2, 3 and 4 means what? In step number 2, find the middle element in the sublist now. Compare the search element with the middle element in the list. If both are matched, then display given element is present, then terminate the program. Otherwise, check and go to the next sublist. Whether the search element is smaller or larger, go to sublist of a sublist. So these are the 3 steps which are to be repeated for the left sublist if the search element is smaller than the middle element of the entire list. Then if it is larger than the middle element, if the search element is larger than the middle element, repeat steps 2, 3, 4, 5 for the right sublist of the middle element. So first you check the middle element, then decide whether we have to go for the left sublist or the right sublist. If the search element is smaller, then go to the left sublist. If the search element is larger, then go to the right sublist. So repeat the same process until we find the search element in the list or until sublist contains only one element. So go on zeroing in on the sublist on the left side or the right side until you find only one element in the list. If that element is also not equal to the search element, you display it is not present. That is step number 9. If that element also does not match with the search element, then display given element is not present and terminate the function. The advantage of binary search algorithm is that it is time independent. Whether it is present in any position, it takes almost same time. Time is almost equal. Whereas in linear search, if the element is present at the beginning of the list, it will display immediately. Time taken for searching is very less. If it is present at the end of the list, the time taken will be very large. Okay, so assume if we have say thousands of elements in the list, then the time taken for searching is very large. Whereas binary search is an optimized algorithm where the time taken will be almost equal to all elements in the list depending on the length of the list. So this is an example that I have taken. So this is a list. I have 1, 2, 3, 4, 5. Totally I have 10 elements in the list with index 0, 1, 2, 3 up to 9. Now I am applying the principle of binary search algorithm to this list and my key element is 31. Now what is the first step? It will do 9 minus 2 to locate the middle element. 9 minus 2 is equal to how much? 4.5. If I do integer division, it is 4. It will go to the middle element which is at index number 4 which is 27. Then this key 31 is compared with 27. Is it equal? No, it is not equal. So then what it does, it will check whether the key element is larger than the middle element or smaller than the middle element. You see here 31 is larger than the middle element 27. Hence it goes for the sublist to the right side, right sublist. So it discards whatever elements present on the left. It chooses the elements which are present here at index 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Okay, this is step number 3. In step number 4, what it does? See, in step number 4, it goes here and checks the next middle element between 5 and 9, which is a middle element. 35 is the middle element. It checks with the 35. Is 31 equal to 35? No. Since 31 is less than 35, it checks the sublist on the left side, left sublist. It comes here. So now it is just 2 elements, 31 and 33. It goes to the first element, which is 31. Okay, so now it compares 31 with the 31. Yes, it is present. It displays successful. So each time it checks the middle element of the larger list, then the middle element of the sublist, again the middle element of the sublist, till it finds only one element or 2 elements depending upon whether it is even list or odd list. Okay, so in the next class I will write the program for binary search and explain it. Thank you.